So when we have to graph all these other trig functions, well, like the tangent here, what you want to think about is think about the unit circle. Think about these points on the unit circle, and we got all those other ones, but these are the important turning points as they were with sine and cosine. And if we think about those coordinates, and you also think about that tangent is the same thing as sine divided by the cosine, or y divided by x. If I take, for 0 degrees or 0 radians, if I take 0 divided by 1, I get 0. And that's where you see that there. And then as you start getting closer and closer to pi over 2, or 90 degrees, notice that the y side gets longer, the x side gets shorter, right? So the tangent's getting bigger and bigger and bigger and bigger until just about, I mean, if you were to type in your calculator and find the tangent of 89 degrees, or the tangent of 89.9999 degrees, it's going to get very large. So what's happening here at pi over 2 is there's a vertical asymptote. And then if you think about it, tangent's positive here, we're going to skip over that vertical asymptote, and tangent's negative over in quadrant 2, and that's why we're seeing it jump over the vertical asymptote and come down here. It's almost acting like 1 over x. Not because it's a mystery either, right? I mean, you think about y over x. Okay, so that's what happens, and that's what the graph of tangent looks like, and it just repeats. Now, I want you to look at that. How wide is that before it repeats? If you said pi units, you're right, because and actually look at this too. Yeah, we didn't talk about negative angles of rotation. Over here, it's negative, and notice how the tangent is below the x-axis. So as I approach negative pi over 2, it's going down to negative infinity, because look at that. That y side is getting very large, very negative, and the x side is getting very small. So we're going to negative infinity. And then as soon as you jump over, tangent's positive over here, and we're seeing it on the graph. So now to go back to that other question, how wide is it before it repeats? And you can almost see it here. It's pi wide. So the domain of the pi function, or the period of the pi function, is pi, as you see right there. And if we want to find, so if I told you like this function here, we want to figure out the period of that function. Well, pi divided by pi over 6, and I'm using pi because it takes pi units to get there, to have it repeat. So pi over 1 times 6 over pi, the pi's cancel out, and I'm left with a period of 6. And if you notice this, you see how it's coming, this is a different graph, sorry. And it's got an amplitude of 3, so that means it's stretched, so it grows a little faster. That's really not too big an issue, and I'm honestly not too worried about you, other than be able to recognize a tangent graph. Being able to recognize a cotangent graph is important, but knowing where the period of a tan function is important as far as solving equations where we're going to go with this. So I hope that helps you with the tangent function. Now I'm showing you the graph of the cotangent function, and let's decide where this is all coming from. So here's this unit circle again, right? The circle, we got a coordinate, so 0, 1, 0, negative 1, negative 1, 0, and 0, negative 1. And we know cotangent is the same thing as x over y, or the reciprocal of the tangent, right? So if we think about this, why does this have a vertical asymptote at x equals 0 when the tangent didn't? The tangent crossed through that. Well, if you take x over y, you get 1 over 0, which is undefined. And then it's okay at pi over 2. 0 divided by negative 1 is 0. Look at that. And then same thing. So we've got a vertical asymptote at pi because negative 1 over 0. So it's the same as the cotangent graph, just slid to the right, pi over pi units. But what else are you noticing that's a little different? Well, with this picture, I'm showing you the graph of the tangent right along with the graph of the cotangent. I'm seeing that the cotangent has the signs switched compared to the tangent. So why is that happening? Well, let's see here. I know that tangent's positive here, it's negative here, and if this function is defined, remember we're talking about the red graph here. Okay, I'm starting here, I've got 0 here, I'm continuing there, then I got my other vertical asymptote at pi. Notice how it goes from a positive to a negative, so it's also reflected around the x-axis. Pretty easy, same period, pi wide, so you can deal with it that way. Not hard. So if we have to graph the secant, one way to do it is to graph. Notice how they've got the dotted cosine graph there. Graph the cosine, and then you know wherever the cosine's equal to 0, the 1 over 0 is going to be undefined. So we've got some vertical asymptotes going on here where the cosine graph crosses the x-axis, and then the graph just comes down and kisses those peaks because it's the reciprocal. So I mean, it's not bad, it's not hard. Same thing with the cosine, or cosecant. Graph the sine function, and wherever the sine function has a 0, there's a vertical asymptote for the cosecant. Okay, and it has the other nice things about it. It's got the same period as 2 pi. So that's what lets us think about doing this. If you graph the reciprocal of whichever function you're looking at, then it's easy to graph the reciprocal function. So to graph cosecant, we're going to pretend we're going to graph the sine. We're not going to pretend, we're actually going to do it. And then we're going to graph the reciprocal. So I'm seeing a sine graph that's been shifted up 1. So that's the midline at y equals 1. It's got an amplitude of 2, so above the midline I'm going to draw 2 lines. Below the midline I'm going to draw 2 lines. It's not been shifted left or right because there's nothing in there, but the period's a little different. So let's think about 2 pi divided by pi over 2. Well, that becomes 2 pi over 1 times 2 over pi, because we took the reciprocal of that. The pi's cancel out. I'm left with 4. So I'm going to come over 4 lines. Label that 4. Half of it's 2. Half of that's 1. 1, 2, 3, 4. I think I'm going to do 2 cycles. I'm going to come to -4 and -3, -2, -1. And the sine starts at the midline. I'm going to go up 2, come back down to the midline, go down 2, back to the midline. Okay, so that's so then I'm going to come down 2, back to the midline, max out, back to the midline. So that's the sine graph, but we want to graph the cosecant graph. So what I do is, wherever this sine graph crosses the midline, I'm going to have a vertical asymptote. And then I'm going to come up, and it's going to come up and it's going to kiss that graph. I'm not going to be able to draw too well there. Okay, and you see how it's alternating? And now let's see if they'll let me delete this blue line. I don't know if they will. Nope, it's going to make me do the whole thing. Okay, so this blue line isn't the graph we're looking for. We're really looking for these black graphs that I did. Okay, so I hope that helps. Why don't you try graphing? Okay, actually, we can do this. Let me try graphing that for you. Actually, why don't you do it? Graph that line, graph that curve, then try sketching in the secant. And then come on back and look what I do. So here's the graph they gave us of the cosine. Now to graph the secant, every place, so think about the midline being here. That's the midline. Every place that midline equals 0, that graph crosses the midline, we're going to put a vertical asymptote. Notice how it's just kind of shifted from the sine, right? And then we're going to have it come down, kiss the graph. Whoops. Over here, I'm going to only draw that part of it. Same here, come down, kiss the graph, cross the asymptote, up, kiss the graph. Okay, so that red graph is the graph of the secant. So I hope that helps.